Hello, welcome back to the channel. So let's continue our discussion on separable differential equations and let's do a smaller word problem on a differential equation. So in this question, you have been given that there is a function f of x which is always positive. So you know that if f of x is always positive, you mean that your y or your f of x function, since you also know that your y is f of x, and since we are given that our f of x is positive, it means it's basically greater than 0, right? And you also know, you also have the initial condition which is f of 0 equals e, and you also have been given the differential equation over here. So you see the differential equation is f dash x equals x f of x, and if we assume, in this case, if we assume our y to be f of x, right? If we assume our y to be f of x, we can write this equation as simply, since this equation is f dash x equals x f of x, we can write this equation as simply, since f of x is also y, so f dash x will be, can also be written as dy by dx. It would be x, and then f of x is y, so we can write f of x as y again. And now you can clearly notice in this case that this is a separable differential equation. You can separate y on the left hand side, and you can keep all the variables of in terms of x on the right hand side. So you'll be able to easily solve this differential equation using the separable differential equation methods, right? That we already covered in the last videos. So let's do that. And we also have been given the initial condition, so we'll get the final answer as well. And if we do that, it's basically dy by y equals x dx, and then we can integrate both sides. So if we integrate both sides, the left hand side is ln of absolute value of y, the right hand side would be x squared by 2 plus the constant of integration. And now once we got our final expression, let's use the fact provided in the question. So you have been given that your f of x is always greater than 0, which is your y as well, right? So if you know that your y is always greater than 0. So since our y is always greater than 0, we can get rid of this absolute value, right? Because taking the absolute value of a positive number or not taking the absolute value of a positive number are the same thing, right? So we can write this equation based on this given fact. We can write this equation as simply ln y equals x squared by 2 plus c, and now we can use the initial condition given. So we have been given that f of 0 equals e. So you have been given f of 0 equals e, and now since you know that you have assumed your y to be f of x, this equation basically means that when your x is equal to 0, your y is equal to e in this case, right? So let's substitute these x and y values in this equation. And if we do that, we'll basically get ln e equals 0 square by 2 plus capital C. So our constant of integration will then be ln e is 1. This expression is 0. So your constant of integration will be 1 at the end, right? And now we can get the final function expression. If we get the final function, our final function would be ln y equals x squared by 2 plus 1. And now you know that generally in order to give the solution to a differential equation, we express the functions in terms of y equals f of x. So y in terms of x. So let's do that. And in order to do that, we can just take the exponent on both sides. So if we take the exponent on both sides, the left hand side and the right hand side, we will get y on the left hand side and e to the power x squared by 2 plus 1 on the right hand side, right? So now this would be your final answer, your final solution to the differential equation provided in the question, which also follows these two conditions given in the question. So your f of x is always positive. Since you realized that you got f of x to be an exponent function, you know that your function will always be positive. It also satisfies the initial condition and also satisfies the differential equation. So that's it for this video. We'll do more word problems in the next videos in order to get the good idea about differential equations which are based on word problems. So feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.